All right, everybody, hello. We're back again, still dealing with polynomials. This time we're going to be solving some polynomial functions, okay? Some equations with some big exponents and things, and then we're just going to talk through how we solve these, okay? I'm anticipating needing to use this board over here to solve some of these, but we will have some more examples after these two as well. Okay, so the directions say solve the quadratics listing the real and imaginary solutions. Remember what these words mean. Real is just like a normal number. And then imaginary solutions are when we have those negative radicals, we write it in terms of I, right? Like plus or minus 2I or whatever, right? So, okay, so when we solve this, a couple things we want to look for, okay? The first thing we want to do is get all terms on the same side, okay? Because again, it's different from equations that we solve in like Algebra 1 where we kind of isolate the x. With these different exponents on the x's, they make them not able to combine, so we can't cancel it out the way that we did with some of the other equations that we've done. So what we need to do is get all the terms on the same side and try to factor, okay? And what we also want to do after this is look for a GCF, okay? Those common factors that all the terms have that we can factor out of the group, okay? Because that's going to allow me to solve it more easily, okay? So doing that for number one here, okay, we have 2x cubed minus 5x squared equals 3x. Okay, so again, I want to get the terms on the same side. So I'm going to minus this 3x. And I would combine it with one of these two, but these two have different exponents than this one. So in that case, I would just kind of write it as its own separate term in this group. So it becomes 2x cubed minus 5x squared minus 3x equals 0. And then from here, I look at my terms, right? And sometimes we can factor these, right? We can factor using tic-tac-toe or whatever. But in this case, what I notice first is, right, all three terms have an x, right? So in that case, I can factor out the GCF of x, right? And my coefficients don't have any common factors, so I couldn't factor out like 2x or 4x or whatever. I have to keep it as just x, because that's the only thing these terms have in common. But again, factoring just means like reverse distributing, right? So I'm going to reverse distribute this x, so like divide it out of each term, okay? So I'll get 2x squared minus 5x minus 3, right? Just decreasing the amount of x's that each term has by 1, okay? And then from here, I look at this remaining group, this 2x squared minus 5x minus 3, okay? Right? This x is already kind of separated, right? And so what I would want to do, right, because if I'm able to factor this group into two separate groups, that would allow me to solve it using what's called the zero product property. And that's something we've done before. But I would need to try to factor this. Okay, so I'll do that over here. So I would try to factor this using tic-tac-toe, right? That's the strategy I teach. And so 2x squared. Again, I wonder like what multiplies to get 2x squared? And that would be 2x times 1x, right? Equals 2x squared. And then I think, okay, what multiplies to get negative 3? And that's pretty easy. That would just be negative 3 times 1 or 3 times negative 1, okay? But the key is that I have to choose a combination of numbers that when I add, it's going to add to negative 5x, okay? And this 2 and 1 kind of throws it off too because I need to put the 3 and the 1 in the right places, okay? So what ends up working, just for time, what ends up working is negative 3 here and positive 1 here, okay? Because when I multiply across, 2x times negative 3 would be negative 6x, and 1x times 1 would be 1x. And then when I add these to check, 1 plus negative 6 gives me that negative 5. Okay, so remember, these now are my two factor groups. So this does factor, which is good news. Okay, so that makes it easier for me to solve. So I'll get x times those two groups that I've circled across the diagonal. So 2x plus 1, and then x minus 3, or 1x minus 3. Okay, so now I have factored this into as many small groups as I can. Okay, let me rewrite this over here. And so again, kind of like what we said with the little groups when we were talking about zeros and factors there, we can take each of these groups, and each of these is going to give me a different answer for x. Okay, so like this single x by itself, right, it's kind of setting each individual group equal to 0. So any x that's just kind of by itself, not in a group, just would equal 0. And then 2x plus 1 equals 0. That's going to be my second one. And then when I would solve that for x, right, this is when I can solve like normal. So minus 1 from both sides, 2x equals negative 1. So from the second group, we would get the answer x equals negative 1/2. Okay. And then this third one, x minus 3 equals 0. So x would equal positive 3, right? With these groups, without a coefficient on the x, we can just flip the sign around, right? We learned that with zeros and factors. So these are my three answers to this problem, okay? So it's similar to solving like a quadratic where you would get all the terms on the same side, factor it, and then get your answers from there, okay? Now this number 2 is going to be a little different, so we'll go through that one, but I'm going to have to erase some of this to make some room, okay? Okay, now, so looking at this number 2, 3x to the fourth plus 12x squared equals 6x cubed, okay? So same idea. I want to start this. I want to get all the terms on the same side. So I'll minus the 6x cubed, cancel that. Okay, so when I do that, I'm left with 3x to the fourth. I'm going to sneak this negative 6x in the middle because that's in between those two exponents. Okay, so minus 6x cubed plus 12x squared equals 0. Okay, so get all the terms on the same side so that the other side says equals 0. Okay, and now I want to look for a GCF. So that's the highest thing that I can divide out of each term. Okay, and we did this in Algebra 1, but can you look at your x's? And all of these have at least two x's. Okay, so I'm going to be able to divide out an x squared from each term. Okay, and then you look at your coefficients, 3, 6, and 12. Those have a common factor of 3, right? 3 multiplies to get each of these numbers. So we can divide out a 3x squared. Okay, that's what's meant by GCF. Okay, so basically it's going to be dividing each of these terms by 3x squared. And I'm not doing a great job of showing all my work, but if you just go down the line, divide these by 3x squared. This first one you would get 3 divided by 3 is 1, x to the fourth divided by x squared, just x squared. And then the next term, minus negative 6 divided by 3 would be negative 2, x to the third divided by x squared, x or x to the first, okay? And then 12x squared divided by 3x squared will just give you a positive 4. All right, so we've factored out this 3x squared from everything. We made the group smaller, okay? Now, when you look at this remaining group, this x squared, again, I wrote 1x squared, but you don't really need the 1, okay? So x squared minus 2x plus 4, okay? If you tried to factor this and answer the question of like, okay, what multiplies to get 4, right? Because this is going to be x times x here. But what multiplies to get positive 4 but adds to get negative 2, that doesn't work. You're not going to be able to find a combination of numbers that works for that, okay? So unfortunately, we can't factor this trinomial. So because that didn't factor, I instead am going to have to do my only other option for solving a quadratic, right? Because this group is a quadratic with an x squared. So unfortunately, I have to do the quadratic formula to just this part right here. So if I do that up here, I'm just going to just take that group, x squared minus 2x plus 4, right? And I know I have the 3x squared over here too, but I'll take care of that part later. So just for this part, I'm going to do the quadratic formula, okay? So that, again, we want to identify our a, b, and c values. So there they are, and it's just putting those into that formula. So here it would be 2 plus or minus big square root of b squared minus 4 times a times c all over 2 times a, right? That's that quadratic formula. And then we would go about solving this and simplifying it down, right? So 2 plus or minus square root of 4 minus 4 times 1 times 4 would be 16 over 2, okay? And then 2 plus or minus square root of negative 12, that would be. And so right here at this point, what you notice is I have the square root of a negative, okay? Because again, remember, we're finding the real and imaginary solutions. So anytime you solve a quadratic like this, you have the potential of having an imaginary answer, but you still have to account for those, okay? You still have to write them as you would if you solved it. So from here, we would keep simplifying, right? You remember our rule with negative radicals, okay? We would take out the negative, and again, a negative like the square root of -1 is what I is equal to, okay? So we could basically say that's the same as I times the square root of +12, okay? And then that square root of +12, that's not a perfect square, but you remember what we can do with that is just do our factor tree. And again, I have a pair of numbers that can pull out of that radical to simplify it, right? This pair of 2's. So that's going to come out of the radical as well. So it's going to be 2I times the square root of 3, right? That single 3 is left in the radical, okay? So that's what this simplifies to, okay? So it would be 2 plus or minus 2I times the square root of 3 over 2, okay? And then from here, yeah, I can divide both of my terms by 2, right? Like this is saying. Basically cancel those. So my answer would be 1 plus or minus I times the square root of 3, okay? For just that part, right? For just this part of it, my imaginary solutions that I would get is 1 plus or minus I square roots of 3. And those obviously would be imaginary solutions because they involve that I. So that's part of it, okay? And then this part right here, right? So I dealt with that part. I didn't deal with this second part here that I factored out from before, right? This 3x squared. So in that case, and that's easier, right? I said like with this problem, this single x resulted in the answer x equals 0. So it would be the same idea. I would say 3x squared equals 0, right? And then I would just solve. So 0 divided by 3 is 0, and then you take the square root of both sides. So basically that ends up being x equals 0 as well, and that's a real answer, okay? So the x equals 0 is real because it doesn't involve an imaginary number, but then this would also be a solution, but it is imaginary, okay? That's a little bit of factoring and solving. Okay, I'm actually going to split this into 2 videos. So the SOAP part of it will be in the next one, okay? Because I know that's a fun acronym here. But so there's some simple ones: solving quadratics or solving polynomial functions. Solving polynomial functions with factoring or the quadratic formula, okay? So good job, guys. Here we go with video number 2.